Today we're going to be talking about representations of functions by power series. Um, and so basically, the idea behind this is we're going to be looking at, for a few examples, we're going to be looking at the functions and we're going to be trying to get power functions that look like these. Ooh, I have some fun stuff happening in this. Okay, so the first example is this. And right away, when you see a fraction, look at it like it could be a geometric. And that geometric is going to be, remember, the sum of that function is going to be a over 1 minus r. So you want to get it looking like this in some way. So there's a couple ways to do this. Remember that you want this ratio here, you don't want it to be x minus something. Okay, you want to leave it as just an x. So what I see right away with my function is that I can factor out a 4. So I get this to be a 1, which is what I needed, and I get this to be a minus a 3x over 4, where I'm not adding or subtracting inside that because that's going to end up as our r. Rewriting this a little bit, we have 1/4 on the top, 1 minus 3 x to the 4th, where a, our first term, is 1/4, and our ratio is 3/4 x. So writing this as a sum, find the power series. So writing this now as a sum, we have, I don't know why it's negative, we have our first term, okay, because remember our power series when we write it is going to look like ax to the n. So I need an x to the n. Since this is geometric, okay, this ratio, the absolute value of our ratio, has to be less than 1. So negative 1 less than 3/4 x less than 1. Multiply both sides by 4/3. Okay, so there's my interval of convergence. And there is my power series. Okay, so now for this one, we want it centered at 1. So this one's going to have a little bit different of algebra to it. And when I was originally doing these examples, quick story, the one previous to this, I was having it not centered at 1. Okay, and then I realized it when I went to this example. I was like, oh, how I was doing that other example wasn't centered at 1. I'm sitting here at my kitchen table. My husband looked at me. He's like, well, duh, I knew that. I said, you don't even know what I'm talking about. Anyway, okay, I digress. So we want to write this function basically so that I have something as 1 minus my ratio here, but this has to be some version of x minus 1 since my center's at 1. Okay, so for this function that I have, I kind of want to manipulate this. I want to manipulate this, and I'm going to write it so that it is 3. I break down into 1 plus 2. Remember, our function is a over 1 minus r. So if I write this as 1 minus, I factor out a negative from both of those terms, I get 2x minus 2. When technically solving that, that gets us to x minus 1. Okay? So in this case, our a1 is 1. Our r is 2x minus 2. Okay, so my summation formula, because I made this look like a geometric series, n equals 0 from 1, my first term, to x minus 2 to the nth. And you can manipulate this, writing this a little bit differently. If I factor out a 2, now it looks like I have a series centered at 1 because of this x minus 1. Again, remember these are geometric. So my ratio, which is x minus 1, has to be less than 1. If I add 1 to both sides, if I add 1 to both sides, that's how I get that. I have something very different in my notes. Very good. Okay. But I know that that's the right answer, okay? Okay, now on to a few other things. Find a power series for this function centered at 1 and determine the interval of convergence. Okay, so what I want you guys to recognize is we just did an example where we wrote a power series. So we wrote this function as a power series. Okay, if I integrate Okay, if I integrate this left side, doing your U substitution and all that stuff, we get this. If I integrate the right side, we get C plus, now the series, I integrate this with respect to X, so the only term I'm really integrating is that, so I get X plus 1. I don't know why I did a plus 1, because I was thinking of adding 1 to your exponent. Add 1 to your exponent, 1 over your new exponent. Okay, so if I let x equal 1, c equals 0, just basically, my best explanation on that one is we're trying to get rid of the c. Okay, so our power series is this. And I don't know why in my notes I don't have this, but what I have written here is I have now, if n equals 0, I have x minus 1 plus 2 over 2, x minus 1 squared, and so on. So technically this is the power series. Okay, and I have this little note here just for myself. We also need to find the interval of convergence. So we do our limit as n goes to infinity of 2 to the n plus 1 Simplifying that all out, we get n plus 1 over n plus 2 times the quantity 2 times x minus 1. And x minus 1's, yes. Okay, so this goes to 1, so this absolute value of 2x minus 1 has to be less than or equal, not less than or equal to, less than 1. Okay, so this is where I have an interesting thing. So now what I do, and I don't think I've made any algebra mistakes because I use this. So now I know that this has to range. If I divide both sides by 2, and I add 1 to both sides, I get something different than what they got. And actually, now that I'm thinking about it, I'm looking at the previous example that I had, and I think I have something that's incorrect on the previous example. So on the previous example, we had this, and that's why I thought I was wrong. But technically, this is not just the thing that's to the n power. Technically, this whole thing is to the n power. So I should have a multiplying by 2 in here. So I should have negative 1/2 less than x minus 1 less than, if I divide by 2, I get 1/2. So technically, I should get that, which is what my book has. And we integrated, we got the same interval of convergence. I just wonder where the book got that from. So I was wrong on the previous example. This example I'm correct on, but I think the book is wrong. And I just wonder where my mistake is or their mistake is. And I want you guys to think about that, maybe get back to me and see. Okay, so for this one, we have a power series centered at 0. Determine the interval of convergence. Okay, so we've talked about how to build power series a little bit. So, and we've built some common elementary power series centered at 0. And hopefully you remember that this function is equal to, it's kind of like a geometric, but just my ratio in this case is -1. But if I want to make this f of x squared, because I want to build a new series, and you'll see where we're going with this. Okay. Now if I integrate, so if I integrate, we get inverse tangent of x is equal to add 1 to your exponent, 1 over your new exponent. Okay, plus c, but if I let x equal 0, the c goes away. Okay, now what I need to do is I need to substitute in now everywhere I see an x, because I need x to the inverse tangent of x over 2. So I need to make this x over 2. So I'm going to substitute that in. What I'm also going to do is I'm going to multiply by a 1/2 out front, multiply by a 1/2, and through a whole bunch of algebra, and simplifying, Remember, you don't have to simplify. You do get what I have here as my answer. Okay, so now comes the finding the interval of convergence. So again, we take this limit as n goes to infinity of the absolute value. So I'm going to ignore this piece, and I'm going to write x to the 2n plus 3 all over 4 to the n plus 2, because this is my n plus 1 term. I just went through and did a whole bunch of simplifying. Okay, so now simplifying that, this simplifies to the absolute value of x squared over 4. Okay, so now, whew, heavy sigh, because this is a hefty problem. This has to be less than 1. So the absolute value of this, absolute value of x squared, has to be less than 4. And I'm not in love with this algebra that I do here. I would yell at my Algebra 2 kids for doing this. When I square root both sides, actually, when I square root both sides, we get x squared, because I've square rooted, x, I can't write today. I'm too focused on something else. We get that. And so that's why our interval of convergence is this. I'm not in love with some of the algebra I did there. What I kind of did was I kind of said, okay, -2 is less than x squared is less than 4, or is less than, okay, I give up. I may have to stop recording videos for the day, everybody. But then when I square root, I'm square rooting a negative. I'm not completely in love with that. But I know that I can put negatives and positives in here, so that's how I know I can have some negatives, but always get out a positive. Anyway, so that's how I know my interval was -2 to 2. Okay? Okay, hope you enjoyed this manipulating functions to get us to a power series video.